So previously, we have discussed about the different types of bonding. हमें पता है that there are three types of bonding: covalent bonding, ionic bonding, and metallic bonding. Metallic bonding takes place between metals, and then you also studied those properties of metallic compounds as well. उसके बाद we also saw ionic bonding. Ionic bonding is between metals and non-metals, and what are the different properties of those ionic compounds? They have lattices and all of that. We also discussed those. ठीक है? Now, when we focus on covalent compounds, now these covalent compounds, when they are formed, now what is covalent compounds? They are made up of two non-metals. ठीक है? They are formed by covalent bonding. When this covalent bonding takes place, what happens between a non-metal and a non-metal? जो दोनों atoms होते हैं, they are both a non-metal, and sharing of electron takes place between these non-metals. ठीक है? Now we call this the bond pair. The one which is shared, we call it the bond pair. The rest of them, which are not participating, let's say, in the bonding, we call them the lone pairs. So there are two types of electron pair. One is the lone pair and one is the electron pair. ठीक है? अब all of these covalent compounds that are formed, they also have some specific shapes. They have some specific names of those shapes, those geometrical compounds. They have a specific geometry. They have an angle as well, the bond angle as well. They have a bond energy as well. And how are we going to determine the shapes of those simple molecules and ions? Let's see these. First, you should know what is an electron pair. Electron pair contains two electrons. Okay, one of them came from one atom, the other one came from the other atom. Now the valence shell electron pair repulsion theory, ये एक theory है, VSEPR theory, that predicts the shape and bond angles. अब इस VSEPR theory जो है, it divides the electron pairs into two types: bond pairs and lone pairs. Now we know that electrons are negatively charged. और जब ये सारे एक ही बॉन्ड में प्रेजेंट होते हैं, they are obviously going to repel each other because this electron is also negative, this is also negative. This bonding with another non-metal, now these are also negative because all electrons are negative, so they are obviously going to repel each other. VSEPR predicts the shape and bond angles of the molecules. क्यों? क्योंकि इसको कहते हैं valence shell electron pair repulsion theory, that the electron pairs in the valence shells repel, due to which the bond shape and the bond angles of the molecules are actually determined. In a molecule, the bonding pair of electrons will repel other electrons around the central atom, forcing the molecule to adopt a shape in which these repulsive forces are minimized. And when determining the shape and bond angles of a molecule, the following VSEPR rules should be considered. Now, valence shell electrons are those electrons that are found in the outer shell. For example, now these electron pairs repel each other as they have the same charge. Lone pair electrons repel each other more than the bond pair. तो जो repulsion है, due to the lone pairs, that is more than the bond pairs. Now, repulsion between multiple and single bonds is treated the same as for the repulsion between single bonds. And the repulsion between pairs and double bonds would be more greater. अब एक जो pair है, a pair of electron and double bond, वो और ज़्यादा repulsion होगी. So the most stable shape is always adopted by those compounds so they can actually minimize that repulsion force. Now, every molecule wants that they should minimize that repulsive force because there's repulsive force in all the molecules. And every molecule would want that there should be the least repulsion. So they're going to put their electrons away from each other. Let's say अगर एक oxygen molecule है, ठीक है, and it is bonded to hydrogen atoms. Now यहाँ पे एक electron है, यहाँ पे एक electron है. Now he knows that there's an electron repulsion taking place. So what are they going to do? They are going to move these away. This is known as valence shell electron pair repulsion theory. That due to the repulsion between the electron pair in the valence shell, the bond angle and the bond shape has to change. Now, different types of electron pairs have different repulsive forces. जैसे कि lone pairs of electrons have more concentrated electron charge cloud than the bonding pair of electrons. And the cloud charges are wider and closer to the central atom's nucleus. तो याद रखें, the greatest repulsion would be between lone pair. Then comes lone pair, bond pair, and the least repulsion would always be between two bond pairs. Highest repulsion जो होगी, which means a large change in angle, that would be between a lone pair and a lone pair. Look at this, अभी H2O की example है. हाउ इज दिस H2O हैविंग अ 105 एंगल? क्योंकि अब यहाँ पे भी इलेक्ट्रॉन पेयर है, यहाँ पे भी इलेक्ट्रॉन पेयर, दे आर ऑब्वियसली रिपेलिंग विच ईदर, तो ये मूव कर रहे हैं। ठीक है, अब ये बॉन्ड पेयर और बॉन्ड पेयर है। नाउ व्हाट अबाउट दिस, यहाँ पे भी तो एक बॉन्ड पेयर था ना, ये तो बॉन्ड पेयर रिपल्शन है बिटवीन दीज टू। व्हाट अबाउट दिस एरिया, यहाँ पे तो लोन पेयर्स थे। ठीक है, दीज लोन पेयर आर ऑल्सो रिपेलिंग बिकॉज दे आर नॉट बॉन्डेड। ठीक है, ये ऑक्सीजन है, दिस इज हाइड्रोजन, राइट? ऑक्सीजन यहाँ है, हाइड्रोजन यहाँ है। द इलेक्ट्रॉन लोन पेयर्स तो ये हैं। यहाँ पे क्या है? बॉन्ड पेयर्स। नाउ लुक एट द टू टाइप्स ऑफ रिपल्शन दैट आर टेकिंग प्लेस ओवर here. Now, between this bond pair and between this bond pair, there would be a repulsion. And between this lone pair and between this lone pair, there would be a lone pair repulsion. तो यहाँ पे भी रिपल्शन हो रही है, लोन पेयर रिपल्शन। यहाँ पे कौन सी रिपल्शन हो रही है? बॉन्ड पेयर रिपल्शन। व्हाट अबाउट द रिपल्शन बिटवीन these one? This would be known as the bond pair lone pair repulsion. ये मिडिल में आएगी. This is a moderate type of. This is the most strongest repulsion. Then comes bond pair lone pair repulsion. Then comes bond pair repulsion. Got it? Is it clear? So the greatest repulsion is between the lone pairs. Then there's the intermediate repulsion between bond pair and lone pair. And then there's a least repulsion between bond pairs. So these are the different shapes of molecules that are in your syllabus: linear, trigonal, planar, non-linear, pyramidal, then we have octahedral, trigonal, bipyramidal, and tetrahedral. And how are you going to determine these? I'm going to give you a table that I showed you previously as well. अब इस टेबल के अंदर whatever molecule you are given, you have to divide the electron pairs into types, whether that electron pair is a bond pair or whether that electron pair is actually a lone pair. You have to decide the number of bond pairs in the molecule and the number of lone pairs in the molecule. Once you have determined the type and the number of lone pair, ठीक है, then you have to remember all of these shapes. कि linear is always 180, trigonal is always 120, non-linear 104.5 है, pyramidal 107, then we have octahedral में सारे right angles होते हैं, tetrahedral में 109.5, and there's a whole sequence for this as well. Let me show you. अब ये बोरॉन है, ठीक है। अब बोरॉन में क्या है? दैट इट हैज, नाउ लुक एट द, ऑलवेज लुक एट द सेंट्रल एटम। द फर्स्ट रूल in determining the shapes and angle is first always look at what? The central atom. What is the central atom in this case? Boron. Boron is the central atom. It has electron pairs as well. ठीक है, इलेक्ट्रॉन पेयर्स की दो कैटेगरीज होती हैं, बॉन्ड पेयर एंड लोन पेयर. कैन यू टेल मी हाउ मेनी बॉन्ड पेयर्स आर देयर इन दिस बोरॉन? Three. Look at this. One, two, and three. Are there any lone pairs in boron? Zero. तो ये क्या हो जाएगा? When bond pairs are three, lone pairs are zero, the shape would always be what? इनका एंगल हो जाएगा 120 डिग्री and the shape would be a trigonal planar. शेप क्या हो जाएगी? ट्राइगोनल planar. अब एक और एग्जांपल है यहाँ पे. Look at CO2. Now there are four electrons in the CO bond to repel each other. अब look at the carbon. ठीक है, look at the central atom again. ठीक है, how many bond pair does it has? 1, 2, 3, 4. It has 4 bond pairs and 0 lone pair. It's going to be a linear molecule. अब यहाँ पे देखिए, यहाँ पे भी देखिए क्या है, 4 bond pairs हैं, 0 lone pair है. वहाँ पे एक्चुअली नहीं, ये गलत लिख दिया, यहाँ पे 2 bond pairs हैं and 0 lone pairs हैं. 4 bond pairs and 0 lone pairs होंगे, so you would have an angle of 109.5. अब यहाँ पे क्या है? Look at the central atom. How many bond pairs do we have? 3. And how many lone pair do we have? 1. तो अगर आपका 3 1 होगा, then the angle would be 107. ठीक है, look at this. यहाँ पे लिखा हुआ है कि so if we have 4 bond pairs, 0 lone pair, the angle would be 109.5 and tetrahedral always. If we have 3 bond pairs, 1 lone pair, angle हो जाएगा आपके पास 107 and it would be a pyramid shape. what if we have two bond pairs and two lone pairs, 2 2, तब आपके पास एंगल जो है वो हो जाएगा 104.5 and the shape is going to be non-linear. Is it clear? Good. Speak a bit louder, ठीक है? I can't hear you. Then we have another atom. अब यहाँ पे देखो SF6. SF6 तो octahedral है क्योंकि यहाँ पे they are all having right angle. ठीक है? Then we have this as well. अभी trigonal pyramidal है. Different है. कहीं पे there's a 120 degrees, कहीं पे there's a right angle as well. So it all depends on if you remember the. अब आपको कुछ चीजें याद रखनी होंगी ना. For example, 4 0 होगा तो 107 एंगल होगा. इफ इट्स 3 बॉन्ड पेयर्स 1 लोन पेयर तो 107 होगा. 4 बॉन्ड पेयर 0 लोन पेयर का मतलब है 109 डिग्रीज. 3 1 का मतलब है 107. और अगर 2 बॉन्ड पेयर 2 लोन पेयर होंगे तो 104 होगा. एंड यू हैव टू रिमेंबर ऑल ऑफ दी शेप्स एज वेल. इज इट क्लियर? Now here you can see we have an example about VSEPR and the shapes of molecule. Draw the shape of the following molecule. The first one is phosphorus 5 chloride. Now, phosphorus is in group number 15, so it has 5 valence shell electrons, okay? And chlorine is in group 17, so it has 7 valence electrons. Now, 5 electrons are used to form covalent bonds with Cl, and there are no lone pairs. क्यों? क्योंकि Cl भी 5 है, and phosphorus also has 5 electrons. So it is going to bond all 5 sides. और जब 5 bonds हो जाए तो remember there's a 90 degree as well and there's a 120 degree as well. फिर आता है नाइट्रोजन. हाउ डू वी डिटरमिन NCH33? अब ये भी देख लेते हैं. नाउ नाइट्रोजन इज इन ग्रुप 15, 5 वैलेंस इलेक्ट्रॉन्स. कार्बन 4 वैलेंस इलेक्ट्रॉन्स. अब ये क्या है? नाइट्रोजन. इट इज बॉन्डेड टू 3CH3 on all 3 sides. ठीक है? It is bonded to 3CH3. Now जो नाइट्रोजन है आपके पास, nitrogen you already know has 5 valence electrons. 3 of them are bonded, 2 of them are not bonded. Carbon is in group number 4. Carbon is in group number 4, which means that it has 4 electrons. So one is bonded here, one is bonded here, one is bonded here, one is bonded here. यहाँ पे भी ऐसा ही है. 1 2 3 4. 1 2 3 4. Now look at the central atom. The central atom has how many bond pairs? Can you tell me? Yes. Speak a bit louder. I can't hear you. There's some mic issue.
Can you hear me now?
Yes, I can hear you. How many bond pairs are here?
In 3,
And lone pairs?
1.
Good. तो मैंने क्या बताया? When we have 3 bond pairs, 1 lone pair, तो आपके पास एक
107.
triangular pyramid shape बन जाती है and a bond angle of 107. Good
7.
job. ठीक है. फिर हमारे पास थर्ड एग्जांपल क्या थी? CCl4. CCl4. Carbon has 4 valence electrons. ठीक है. And we also have 4 Cl attached. तो यहाँ पे तो 0 lone pairs हो जाएंगे then in this case, which means it's going to be a tetrahedral because there are 4 bond pairs and 0 lone pair and an angle of 109.5. Clear? Because it's 4 bond pairs and
Yes.
0 lone pairs. Good. Next we have bond polarity. What is bond polarity now? First of all, before bond polarity, you should know what is electronegativity. एक term होती है हमारे पास, electronegativity. Electronegativity is basically, you can say, the tendency to gain electrons. It is the tendency to gain electrons, which means that if we have, let's say, Br2 का molecule है, Br, and I know that they have a covalent bond between them. One of them might be more electronegative. अब ये तो electronegative एक ही जितने हैं, ठीक है? They are the same atoms. They have the same electronegativity. Because when you look at a periodic table, remember, जो electronegativity होती है, that always increases as you go right and up the periodic table. जब आप right और up जाते हैं in the periodic table, the electronegativity always increases. Now bromine तो दोनों एक ही position पे, so they have equal electronegativity. So this is going to be a non-polar bond. क्योंकि polar से आप example ले लें, polar means charged, ठीक है. What if we have HCl? HCl ले लेते हैं. We know HCl has also formed a covalent bond between hydrogen and chlorine. Now, the thing is, chlorine is present somewhere here on the periodic table. Hydrogen is somewhere here on the periodic table. Which one is more electronegative? Can you tell me?
Chlorine.
Exactly. Chlorine would get a partial negative charge and hydrogen would get a partial positive. The one which is more electronegative would always get a partial negative charge, and the one which is less electronegative would get a partial positive charge. We can't call them positive and negative क्योंकि वो तो ions हो जाएंगे. Partial positive and negative means it's just a temporary one. So the more electronegative one would, the electrons would always be closer to the more electronegative one, which means if this is the bond, this is where the electrons will be present closer to this chlorine. So this is what we call a polar bond or charged. Is it clear?
Yes.
So electronegativity is the power of an atom to attract the pair of electrons in a covalent bond towards itself. The electron distribution in a covalent bond between elements with different electronegativities will be unsymmetrical, and the phenomenon arises from the positive nucleus's ability to attract the negatively charged electrons in the outer shell towards itself. And a Pauling scale is used to assign the value of electronegativity to each atom. So you can see that as you move towards the right, on the periodic table, and as we move above the periodic table, electronegativity is increasing, which means that fluorine is the most electronegative atom in the periodic table. And whenever there's a difference, अगर मैं compare करूँ, let's say if I compare boron and hydrogen, now अगर इनका covalent bond बनता है, ठीक है, it won't be a polar bond because they almost have the same electronegativity. So there should be a difference in electronegativity to make a bond polar. Now the first three rows of the periodic table showing electronegativity's values. Fluorine is the most electronegative atom. It has a value of 4. You don't have to remember the values. ठीक है, it's just an idea. मैंने आपको बता दिए right पे and ऊपर. It's going to be the most electronegativity. So fluorine would be the best at attracting the electron density towards itself. ये नहीं कि it's taking away the electrons. I'm just saying that if there's a bond of hydrogen fluoride, अब ये भी एक covalent compound है. And we all know that covalent compound तो charge नहीं होते थे. They are sharing electrons. There's not a transfer of electron. But it has a slight partial negative charge. It has a slight partial positive charge. जो इनके दरमियान जो electron pair है, it's not being broken. It's not being taken away. It's not being losing or it's not transferring. It's just getting a bit closer to fluorine. ठीक है, it's just distancing itself from hydrogen. It's not that it's leaving, it's broken, it's transferring. No, it's just a bit closer to fluorine when it's in the bond. Got it?
Yes.
Because fluorine is more electronegative. For example, अब कार्बन और फ्लोरीन का अब यहाँ पे CNH almost have the same electronegative. तो इनका electron pair यहीं पे हो. But the electron pair between carbon and fluorine is going to be more closer than fluorine because fluorine is more electronegative than carbon. So both electrons are attracted to the fluorine. Now, attraction exists between the positively charged protons in the nucleus and negatively charged electrons found in the energy levels of an atom as well. And an increase in the number of protons leads to an increase in nuclear attraction for the electrons in the outer shell. Therefore, an increased nuclear charge results in an increased electronegativity as well. फिर atomic radius. What is atomic radius? The distance between the nucleus and the electrons in the outermost shell. Electrons closer to the nucleus are more strongly attracted towards its positive nucleus. But the electrons that are further away from the nucleus, they are less strongly attracted towards the nucleus. तो उसकी वजह से भी क्या होता है? Increased atomic radius results in a decreased electronegativity. आपकी electronegativity would decrease if your atomic radius is more, क्योंकि electrons are actually very far apart from the nucleus. Then shielding effect affects as well कि बीच में और कितने electrons आ रहे हैं between the nucleus and the outermost electron. One shield, second shield. That also differs because field energy levels can shield the effect of the nuclear charge, causing the outer electron to less attracted to the nucleus. Therefore, The addition of extra shells and subshells in an atom will cause the outer electrons to experience less of the attractive force of the nucleus. जैसे कि सोडियम और cesium है, ठीक है? सोडियम has an high electronegativity than cesium. क्यों? सोडियम ऊपर आता है, ठीक है? जो cesium है वो नीचे आता है, which means cesium has more shells. Sodium only has less number of shells. Thus, an increased number of inner shells will result in decreased electronegativity. अगर आपके number of shells और shielding effect increase होते हैं, then your electronegativity would also decrease. So down the group, there is a decrease in electronegativity, and the nuclear charge increases as more protons are being added to the nucleus. The addition of the extra shells increases the distance between the nucleus and the outer electrons, resulting in larger atomic radii. So overall, there is a decrease in attraction. So here you can see moving down group number 1 from lithium to sodium to potassium, there's a decrease in electronegativity. Why? Number of shells is increasing, more shielding, atomic radius is increasing, the nuclear charge is also increasing. Nuclear charge कह लें या आप number of protons कह लें, ठीक है, that is increasing, and there is less attraction between the nucleus and the outermost electron क्योंकि वो दूर होता जा रहा है. But across a period, electronegativity would increase. Why? Because when you go across a period, the radius decreases and the shielding remains relatively constant because it's a single period, which means that the shell number would be the same. But the nucleus has an increasingly strong attraction for the bonding pair of electrons, so this results in a smaller atomic radii. Across the period, what's happening? The electronegativity is increasing because the nuclear charge increases, atomic radius decreases, and there's a greater attraction between the nucleus and the bonding electrons. Got it?
Yes.
Good.